We're gonna go right on 6. So you let me, yeah. Good evening. It's Roger Denbrook giving the introduction. And it is my pleasure to welcome you to the 9th annual Dr. Pauulu Kamarakafego Memorial Lecture, Bermuda's Changing Climate, Trends and Projections, presented by Dr. Mark Guishard. Dr. Pauulu Kamarakafego was a civil rights leader, political activist, parliamentarian, ecological engineer, and a United Nations NGO worker who used his voice and mind to initiate change and empower people in Bermuda and around the world. In 1960, he formed the Committee for Universal Adult Suffrage in Bermuda to address the issue of reform of the franchise. The work of this organization was directly responsible for the eventual passing of the Parliamentary Election Act of 1963. He died in 2007 and was named a Bermuda National Hero in 2011. The Department of Culture honors his legacy each year with a memorial lecture as part of the Bermuda Heartbeat series, a program which he helped to establish. Dr. Mark Guishard. Dr. Guishard is the director of the Bermuda Weather Service, a section of the Bermuda Airport Authority. Mark is a chartered meteorologist with over 20 years of experience in weather forecasting, disaster management, research meteorology, and catastrophe risk science. In addition, he is a trustee and adjunct scientist at the Bermuda Institute of Ocean Sciences with research interests in natural hazards, climate change, and disaster resilience. He is also the World Meteorological Organization's regional focal point for disaster risk reduction for North America, Central America, and Caribbean. Mark holds a PhD in meteorology from Penn State University, a master's in atmospheric sciences from the University of East Anglia, and is trained at the UK Met Office and the US National Hurricane Center. He is a fellow of the Royal Meteorological Society. Mark has plenty of experience with hurricanes and hopes he doesn't have to gain any more this year. It's my absolute pleasure to welcome Dr. Mark Guishard.
Good evening, and thank you. Thank you for the audience here tonight who's here physically, and thank you for joining us for those of you sitting at home in your pajamas online. I wanted to thank especially Minister Peets and his team and colleagues at the Department of Culture for organizing this event. I'm honored to be speaking here tonight. So climate change and Bermuda, this is what we're going to be talking about tonight. In terms of our sort of outline of the evening's conversation, we'll be first outlining some definitions, look at some detected trends locally, what we see here in Bermuda and what we've measured here locally. the ocean, the hydrosphere, and the land. And this can be measured over periods of years, decades, and centuries, and even longer. And so when we talk about climate change, this is really what we're talking about. The climate itself, our climate here in Bermuda, is changing as it is around the world. Context are, say, hurricane season predictions. We talk about how active the season is going to be. And these are some of the things that we discuss when we think about seasonal timescales. When we think about climate, we're really looking at decades and centuries. And again, here on the left, you will see that we talk about threat assessments when we talk about the weather, but then we look at outlooks and scenarios when we talk about climate change. And along the bottom here, the actual applications that we can undertake if we have this information is preparedness planning. When we're looking at seasonal outlooks, we can look at much more strategic planning, long-term planning, engineering style planning for infrastructure, for example, when we consider changes over decades and centuries. And it's also worth noting on this chart, it nicely highlights schematically that the uncertainty around each of these timescales forecasting the conditions in the atmosphere grows the further out you go. And so the uncertainty around climate change research and model projections is perhaps greater than what we would expect from day to day. And we just demonstrated that by talking about what the conditions in July would be versus what the conditions on a specific day in July would be. Climate versus weather, once again. So as we further explore some definitions, let's think about some of these terms that have been used interchangeably in the past: greenhouse effect, global warming, climate change. So to start off with, we'll consider the Earth without an atmosphere, just a spheroid, a planet in space without any atmosphere. If that were the case, the energy balance on that planet would be somewhere like minus 18 Celsius would be the average temperature for that planet without an atmosphere. Much too cold to sustain life. Thankfully, we have an atmosphere and the greenhouse effect. The greenhouse effect is an aspect of the atmosphere whereby heat is actually trapped by some of the gases within the atmosphere, and it acts as sort of a blanket around the planet. And so with that greenhouse effect, with those greenhouse gases that lead to that greenhouse effect, such as carbon dioxide, and you can see again in this animation, sort of radiation coming in towards, say, a schematic CO2 molecule, carbon dioxide molecule, and then being re-radiated outwards. Some of that re-radiated energy goes down towards the surface of the planet. And so some of the energy that's coming in from space is kind of trapped in this blanket, if you will, of greenhouse gases. So thankfully, that leads to a warmer average global temperature. Now, keep in mind, we are talking about averages. So this doesn't mean that the temperature around the globe at any given time is 15 degrees. It's the average for the entire globe. And, and thankfully, that is much more a habitable range due to this greenhouse warming that we have, this greenhouse effect, I should say. So what is the problem? Well, the problem is we're starting to, or we have been emitting too many of these greenhouse gases into the atmosphere, which in effect is acting like putting another blanket on the globe, and that's trapping more and more heat. And this is a well-studied phenomenon, a well-understood and an all but certain phenomenon. For decades, scientists have been tracking the level of carbon dioxide in the atmosphere and other greenhouse gases. Carbon dioxide is the most abundant and the one that we tend to focus on because it traps a lot of heat. And its abundance is in lockstep with the rising global average temperature. So we're, again, certain that this is a factor in the warming of the planet, which has been observed for many decades. So pulling this all together, we have global warming, which is produced by this enhanced greenhouse effect, which is in turn leading to climate change. So we're increasing these emissions of greenhouse gases, such as carbon dioxide and others. This is enhancing the natural greenhouse effect that we need to keep the planet warm, and that's causing continued and accelerated warming of the planet, known as global warming. And that is hand in hand, goes part and parcel with this phenomenon we know of as climate change. And climate change has a number of different other aspects to it other than solely the warming surface of the planet. There are many things here that we're going to investigate and look at here tonight. Sea level rise, changes in extreme weather, ocean warming, and various other aspects. So what do we see here in Bermuda? Do we actually detect any trends in some of these things as we look at how Bermuda's climate is specifically changing? And the answer is yes. First of all, based on ongoing studies at the Bermuda Institute of Ocean Sciences, BIOS, they have a number of atmospheric programs, and one has been tracking carbon dioxide in the atmosphere around Bermuda since the 80s. And unsurprisingly, that concentration of carbon dioxide gas is increasing over time, has been increasing, and goes hand in hand, goes lockstep with that global set of measurements of carbon dioxide as well. So yes, we too are seeing carbon dioxide in the atmosphere near Bermuda increase. What is that doing to the ocean? Well, one of the things that is happening is that the ocean is absorbing some of that carbon dioxide and gradually becoming more acidic over time. And for the chemists in the room, that means the pH is lowering over time as well, especially in the surface waters of the ocean. And so that's what we know of as ocean acidification. Now, the excess warming that the atmosphere is holding because of this additional warming that greenhouse gases are providing, over 90% of that excess heat is being absorbed and has been absorbed by the oceans. So unsurprisingly, the temperature of the upper oceans is warming as well over time. So that heat absorption is warming the oceans up, and that, as you'll hear shortly, has a number of different consequences for especially weather. Let's look at some rainfall. So there are different aspects that we can look at in terms of the rainfall record in Bermuda. This is one of them. This is a very complicated aspect of the weather. We tend to think in terms of long-term projections when we think about climate. And the first thing I'm showing you here is annual measurements of rainfall going back to the 1940s. And you can see there's a very gradual upward trend in the total amount of rainfall we're getting year to year. Now, it's worth noting that this detectable trend is not a statistically significant one, meaning there are lots of ups and downs in this trend. you can see that in any given year, you might have way above average rainfall, and in another, the next year, you might have very little rainfall comparatively. And part of that is down to how rainfall varies geographically over the island. Over a short duration, we have a big rainfall event, such as this one in March of 2016, which flooded Woodlands Road and other areas around Hamilton. You would note that in some areas, it wasn't raining as hard as others. In this other example in the map that you can see in 2014, there was a wide variation of rainfall based on automated stations around the island. In the West End, they saw something like 2 inches or more of rainfall, 50 millimeters or more. And in the East End, where all the official observations take place down at LF Wade International Airport, where our station is at the Weather Service, the measurements were of much, much lower, sort of like 4 times lower than the maximum rainfall detected in the West End. So there's this large range. Anytime we have a big rainfall event, there's often this sort of high concentration of rainfall in any given area. This is very unpredictable. And in these short duration, high intensity events, like the ones that cause localized nuisance flooding, there's a lot more work to be done to figure out if there are actual trends in the daily record of rainfall and the shorter time frame record of rainfall. We do know from theory, however, that rainfall amounts and the sort of swings, the highs and the lows of rainfall amounts should start to increase or are likely to increase under global warming. And that's because as the temperature goes up, the atmosphere can absorb and hold more water vapor. And as it holds more water vapor, more available to form clouds and precipitation. For us, of course, rainfall is very important. We have our own individual buildings, water supplies that's entirely dependent on rainfall. We don't have any large river systems here in Bermuda from which to draw large amounts of water, fresh water for drinking. But we do have groundwater as well, which is recharged by this rainfall. And so the impacts on the overall water supply on different timescales, annual, seasonal, daily, hourly, each of those are important for different aspects. Water supply, very important for the sort of 3-month average seasonal rainfall. The daily rainfall is much more important for these flooding events. So this, it's fair to say, bears a bit more research, a bit more delving into to get into some trends. And this year-to-date idea that we paint a picture of doesn't paint the whole picture of how rainfall is changing under climate change. The daily impacts are very important, especially when we have really big extreme events such as hurricanes. And what you can see here is a satellite image and a radar, Doppler radar overlay on top of that from the Bermuda Weather Service of Hurricane Nicole in October of 2016, which amounted to one of the largest rainfall totals here in Bermuda. As Nicole approached that very strong eye wall, which has a lot of rainfall embedded in it, ran right over the island and caused a lot of rainfall locally. And one of the things that is very clear is that rainfall in tropical cyclones, tropical storms and hurricanes, that is, like Hurricane Nicole, is going to increase over time as the planet warms. Here we have that brings us nicely to some other trends in tropical cyclones. And again, that's a generic, a technical term that we meteorologists like to use to say tropical storms and hurricanes. What we see here in the bottom left is a long-term record from the 1800s of all the tropical cyclones, that's tropical storms and hurricanes, that moved within 100 nautical miles of Bermuda. That's our threat criteria. So when you hear the forecast coming out of the Weather Service, if we have a potential threat or a threat means a center of a storm is forecast to come within 100 nautical miles within the next 72 hours. So that 100 nautical miles is a good sort of thing to examine. So these are all the storms that came within that threat criteria range in the bottom left. And the purple line there is the sort of 10-year average of those, the number of those storms. You can see there's a number of, again, bumps and wiggles, if you like, highs and lows, peaks and troughs in the record. But one thing's clear about the record is that it is gradually increasing. So the number of storms coming within range of Bermuda has been increasing over time. Some of this in the early part of the record is probably down to some reporting bias, but certainly since the satellite record, the satellite era in the 1970s onwards, this is a much more robust signal. And if we look at more recently, there's a steeper increase in the number of tropical storms and hurricanes and their intensity in the last 20 years or so. The top three maps that you can see are successive 20-year periods from the 1960s through to the 2020s, looking at the tracks of storms that come within range of Bermuda in the 1960s to the 80s, and then again subsequently in the 80s to the 2000s. We saw on average about 20 storms in total come near Bermuda. Fast forward to this century, this millennium, 2001 to 2020, that number has jumped to 30. So there is a significant increase in the number of storms that we see coming near Bermuda in the last 20 years. And the bottom right graph shows not only their counts, but their intensities as well. And you can see there's also an upward trend in their intensities. All of this means two things. We're getting more storms, and the storms that we get are getting stronger. We'll come back to that point shortly. One of the things that can exacerbate the impacts from storms is sea level and sea level rise. This is also another sort of robust signal that we see, not only globally, but locally. And there's some pretty straightforward science behind it. As the globe gets warmer, the glaciers, the land-based ice melts, that releases water into the oceans. And also the oceans themselves are absorbing more heat, as we heard before, and they're gradually kind of expanding. That's some high school physics for you. You heat something up and it expands. So the combined effect means that the oceans are kind of gradually rising over time. The past, from the 1930s through 2020 or so, we see that increase on the order of something like 2 to 3 millimeters per year. So these are annual average sea levels. And this is based at the tide gauge that's on the north side of St. George's. Now, if we take recent climate projections of how that sea level is going to continue to rise under different scenarios, lowered greenhouse gas emissions, drastically lowered, or business as usual, where we continue to pump lots of carbon dioxide and other greenhouse gases into the atmosphere, we can see a trend of acceleration of that sea level. And there are some error bars, as we said, around this. The further out you go, the further forward in time, the greater the uncertainty. And so those error bars, you can see there, expand. But the red line, the red solid line, and its associated dashed lines either side are the kind of business as usual scenario. And that's what I would like to focus on. In 2017, and then again more recently as well, we saw an oceanographic feature come across Bermuda. And this has happened through history. This is not climate change in of itself, but in 2017, we saw that what we call warm eddy, this warm sort of dome of water, come across the area and the island and cause localized flooding in areas like St. George's that are very low lying. And what this oceanographic feature did was it added about 1 foot to 1.5 feet of water level on top of the baseline sea level that it normally would. And it lasted for days and even weeks. The worst of it lasted days. So if I project that level of extreme event onto this chart of projected future baseline sea level, what we see is that today's extreme sea level events are projected to be within the normal tide range, possibly as soon as 20 years from now. And so to put that in more personal context, by the time my child is my age, this will be the normal high tide. So this is a real challenge. And whether it's 20 years or 25 or 30, this is coming one way or another. And this is something that we need to be prepared for. And if you think that was a fluke, here it is again in 2019, Ordnance Island and Somerset Bridge as well. Same sorts of levels, roughly a foot or 0.3 of a meter of sea level increase in the absence of any other weather feature. So you had a spring tide and you had this oceanographic feature. Now imagine putting a hurricane on top of this. Then you're running into some even greater problems. And by the way, these sea level rise projections, which were made in 2014, they're continually being refined as we learn more and more about, say, ice sheet dynamics in the Arctic regions. And so some of these projections are being refined year on year. This is the same group of scientists that redid their calculations a few years after the paper came out, giving us an indication that that mean sea level might be even higher sooner. So this is all something that's worth considering when we think about not only our day-to-day sort of sunny day flooding, if you will, during spring tides and during sort of peak oceanographic events, but also during other extreme events which may give rise to storm surge like hurricanes. So it's safe to say that when you look at this and project it onto properties, there are some places around the island which are more exposed than others, simply due to their elevation. We've done a few studies, again, at BIOS to focus in and hone in on this idea that some property values and some properties are going to be more exposed than others. The good news is most of our properties are well above that threshold where they're being flooded now, and are probably well above that mean threshold of getting flooded frequently in the future. So there's not a great increase in the number of properties that are exposed, but for those that are, there's something like a 700 times more frequent flood event that they can expect by 30 years time from now. And there's no particular reason I focused in on Mills Creek here, but certainly that's one of the well-known areas, Mills Creek, Bakery Lane, et cetera. These are areas that flood because they're right near sea level and they have not great drainage. One other aspect of the ocean that we should consider during all this is ocean warming. And just like in the atmosphere, you can have heat waves, in the ocean, you can have heat waves, marine heat waves. I'm going to take a minute to delve into this a little bit with thanks to some of my colleagues from BIOS for providing some of this content. The coral reef that we have around the island is made up of coral, which is a symbiotic organism or suite of organisms. And when they are particularly stressed, and heat is one of those things that can stress them, the organism which lives within the coral can be expelled. And that is called zooxanthellae, and it's what gives the coral its color. So when it's expelled, if it doesn't come back, it can lead to what's known as coral bleaching. You've probably heard this term before. And if that bleaching is prolonged, the coral can die and then be eroded. So with increasing numbers of marine heat waves in our ocean surrounding Bermuda, we can expect to see more propensity for bleaching events. Now, there's a lot of studies about how resilient Bermuda's corals are because we are further north in slightly cooler water. We have a sort of very steep undersea platform where corals can sort of survive further down. And there's a lot of academic research going into that, whether there's a refuge for corals further down. But it's safe to say that, and it's also safe to say that ocean warming and marine heat waves are not the only stressor on corals. There are also pollution events or overfishing that can cause damage to our coral reef ecosystem. In terms of chemistry, as I mentioned before, that carbon dioxide, which is being emitted in greater and greater amounts, is being absorbed by the ocean, or a lot of it is being absorbed by the ocean, I should say. That's making the surface waters of the ocean more acidic. And that can be a problem if you're an organism that is building a shell out of calcium carbonate. The more acidic environment that organism is in, the less able it is to build healthy shells. This is probably a longer term effect than the ocean warming and the marine heat waves that we're seeing, but it's certainly having an impact on those microscopic creatures, the zooplankton, and others that sit perhaps at the bottom of our food web. And that food web has implication for fisheries, for tourism, for our own reef, and its protection of our island. So these ecosystem effects can really be a problem for our economy, not just for the natural environment. It's worth noting that the environment and the economy are inextricably linked. The coral reef ecosystem has been valued conservatively to contribute something like $1 billion per year to our economy through tourism, through fishing, and through coastal protection against storm surges and intense wave action. And it's also safe to say that it's part of our culture, part of our Bermudian identity. If you grew up here in Bermuda, you grew up going swimming. You grew up swimming around the reefs and taking note of all the beautiful sea life that we have here. So this is yet another, perhaps less well understood downstream impact from climate change. And then you have some of these impacts that combine with one another to become cumulative in impacts. So the warmer air leads to more evaporation, as we heard, and that leads to more rainfall and storms. Those marine heat waves lead to more, the warming of the ocean over time leads to more of the intense storms. As we probably all know, the fuel that hurricanes use is warm water. So the warmer that water, the greater the abundance of warm water, the more intense the hurricane can get. And of course, sea level rise increases storm surge risk. And the damage to our coral and our food webs can be caused by these warmer ocean temperatures and ocean acidification. So there's sort of multiplicative things that play into one another to compound risk. And there's a lot of feedbacks as well. So looking at one here, that ocean warming thing, which we really are focused on as part of the research that's going on, not just in Bermuda, but around the world. That ocean warming can lead to stronger storms. It contributes to sea level rise, as we've heard, and it can also lead to coral health decline. And of course, stronger storms can also lead to coral health decline. And coral health decline can lead to more inundation risk because you're losing that natural self-building seawall. I've heard one of my colleagues call it in the past. So a lot of risks, a lot of complex feedbacks as a result of climate change. What do we do about all of this? This all sounds horrific and can lead to some despair, but let's think about some of the things we can and are doing about this. There's two main trains of action that we have for climate change, to respond to climate change. One is called mitigation. This is a term that's used to describe the reducing of the causes of climate change. And the other is called adaptation, which is adjusting to the impacts. And as an example here, we have an adaptation plan from one of the counties in Canada to give some idea of what we mean when we say in real terms, mitigation and adaptation. Mitigation is sort of minimizing our carbon emissions by using things like sustainable transportation, cleaner energy. Adaptation is looking at how we build infrastructure, whether or not we have flood protection, whether or not we actually retreat from the coastline in some areas. And then there are things that are aspects of both that can be incorporated into one type of effort. Education is part of that. Building resilience for the natural environment, which can in turn help to protect us through nature-based solutions, is another. Carbon footprint. This is a very clever diagram that many of us will have seen before. It's a little bit outdated, but it paints the right picture. The foot on the left is each of the circles represents the total amount of carbon emissions by country. And so, as you can imagine, Bermuda has a very small carbon emission as a country. And some of the two big players here, we have the United States in green, China in orange there. Bermuda is minuscule. You can barely see it in the grand scheme of things. Now, if you take that overall carbon emission by country and divide it by the population, you get a carbon emission per capita, what each of us on average emits in terms of carbon dioxide. And this is where we really compete with some of the developed countries that consume quite a lot. We're right up there with the United States, and I've said it before, the average person in Bermuda emits more carbon per person than the average person in China. And there's people that say, well, that's kind of obvious. But what it means is that twofold. One is that mitigating our own carbon footprint individually, as well as a country, would be certainly a financially responsible move. It would help to promote energy security. We could rely on much more clean sources of energy. And there's lots of other positives here. It's the right thing to do. It's a moral thing to do. It's something where we can set a good example. None of that is actually going to help the risks that are coming down the pipeline or minimize them for us here in Bermuda because of this on the left. We're so small, we can't possibly have a direct impact on the risks that we face, but we should still be focusing on mitigation on an individual level. And I'll delve a little bit more into this. This is a similar kind of chart showing all of those countries again, and this is for 2020, so much more recent statistics. And it kind of tracks like development, consumerism, the sort of starting from the sort of 3 o'clock level going backwards around the clock. There's an increased amount of carbon dioxide emissions per country. The per capita per person for each country. The world average is around 4, and this is how the world average has changed over time. You can see a downtick in 2019 to 2020 because of the pandemic. Less people moving around, less people building things, consuming things means that there's been a downward tick in the amount of carbon dioxide emitted into the atmosphere globally, which is a good thing, but it's a very small tick downwards. Where's Bermuda in this? Here we are. So each of us in Bermuda emits on the order of 10 tons of carbon dioxide per person. And that's up 17% since the year 2000. We're number 23 in the world. There's something like 240 countries represented here and territories. So this isn't something to be proud of. Each of us individually is contributing to the problem, in addition to entities, large organizations contributing to the problem. So for small islands like Bermuda, we need to be able to adapt in addition to this mitigation piece that I talked about just now. And in order to adapt, we really have to understand what our risk is. What I've been talking to you about tonight primarily has been about the physical hazards that we will face, the increased storm surge, the increased frequency of hurricanes and intensity of hurricanes. That's all about the physical hazard. We need to think also about our own exposure and our own vulnerability. These are aspects of risk that the insurance industry knows very, very much about. So we're fortunate here in Bermuda that we have a high proportion of people that understands this problem of risk and the fact that we need to consider the combination of factors. So in addition to those physical threats, those hazards I talked about, we need to consider less straightforward effects, like what impact does climate change have on food security and on energy security, on supply chain. We've seen a lot of disruption to supply chain in the last couple of years for various reasons, not least of which is the pandemic. But it needs to be said that climate change as a whole can be disruptive to our supply of goods, food, health supplies, et cetera, to the island. So we need to be ready to adapt to these challenges as they come down the pipeline. So this is sort of a call to action, but what's actually being done? And it's safe to say that there's a lot actually being done by different sectors of society. Government, there was great leadership that the government showed by leading the overseas territories at the most recent COP26, Conference of Parties in Glasgow. It also, as a result of that, formed a climate change task force, which has been in the news recently. They commissioned a study on climate change in public infrastructure, which is underway already. And there's been a lot of focus on renewable energy at scale to really bring down those emissions. The electrification of buses, the bus fleet, and aspects of protecting the ocean, like the Bermuda Ocean Prosperity Program. These are all things that government have been doing, and perhaps up until recent years, hasn't been framed in the context of climate change. But these are all things that will help us to mitigate our carbon emissions and or adapt to the coming changes. What about nonprofits, charities? Well, we've talked a little bit already tonight about some of the things that BIOS is doing. I want to thank BIOS and its sponsors for allowing us to do more work in this regard. I also want to thank BUEI, where we are tonight, for really bringing the focus of climate change to youth by hosting the Youth Climate Summit back in November. And it's worth saying that the scientists such as myself, we've been talking about climate change for decades, but it's taken youth activists to really bring the issue to the forefront of the minds of people that are not scientists, people that have decision-making power in high levels of government, in corporations, et cetera, and in the public eye. So I think we should all be grateful for the contribution that young people have made to voicing concerns about climate change and for taking leadership on that issue. And then there's a whole suite of environmental, non-governmental organizations here in Bermuda that have banded together in a climate action network as well. So there's a lot of work that's been done in the nonprofit community, as well as government. And then, of course, the private sector. The private sector is often who is funding and supporting these nonprofits in their work, in addition to those that are supported by government. The renewable energy efforts here in Bermuda really are being led by the private sector. There is, if you look at the commercial and residential efforts to build renewable energy at scale, these are being led by the private sector. And so in partnership with the government, there is real hope for getting toward that sort of very low carbon emission framework by 2035, which is the stated goal. And of course, I mentioned it earlier, there are a lot of people in the island centered around the risk industry, insurance-linked securities, et cetera. And so there is a real opportunity to leverage that expertise, not only to deploy knowledge externally for the benefit of developing countries that need to build resilience, but also to deploy that expertise locally in the effort to try to build our own climate risk framework internally. So to summarize, we've got human-enhanced climate change. We call it anthropogenic climate change, is causing storms to be both more intense and also more frequent here in Bermuda, and also wetter, so more rainfall. Also wetter in terms of the amount of seawater that they can inundate the coastline with, and that's being exacerbated by sea level rise. That warmer ocean is leading to unhealthy coral, or contributing to the decline in health of coral. Ocean acidification is damaging these food webs in the ocean, which we all depend upon as well. And what are we doing about it? What can we do about it? Well, right now, our per capita emissions are very, very high. We all need to work to try to minimize them. And we have to consider that both mitigation of those emissions, mitigation of climate change itself, and adaptation to the coming risks, threats, and increasing threats are underway in several sectors of society, and more work is needed. So it's not to say it's on each of us as individuals. It's down to governments, nonprofits, the private sector, and individuals. All of us have a part to play to mitigate emissions and to adapt to the impacts of climate change. With that, I want to conclude the talk and say thank you to all of these contributors, all these contributing organizations, Bermuda Airport Authority, where I work, of course, in the Bermuda Weather Service, BIOS, a lot of collaborations with academia and the private sector locally and internationally. Thanks very much, and I'll leave you with this slide. I'm happy to take any questions that anyone might have. Thank you for that. And for the audience at home, the question was what my opinion of wind farms is, and is that something that we can go towards? I think that we have an abundance of solar resource here, and we also have an abundance of wind. I think that combining the two is probably our best approach. And I won't profess to be an expert in renewable energy, but I will say that the solar resource is probably more consistent. And we've already seen lots and lots of solar panels on roofs. We need to see more. We've seen large scale solar farms like at the Finger at the airport and on the roof of different large buildings. We need to see more of that. I think that diversifying the renewable energy sources is a smart move as well. I think one of the things that will be potentially a challenge for large wind farms is the fact that we may have a pretty good steady wind resource here, but then we've also got much higher extremes with the hurricanes that we get moving through the area as well. And again, I'm not an expert on that, so I can't speak to whether or not that's accounted for in any wind farm research, but it's certainly something to consider. Sir. So the question is, what impact will sea level rise have on the innovative cesspit system that we have here in Bermuda. The jury's still out on some of that. It's safe to say that a lot of what I've presented here tonight is sort of well-established research. There is some research about how cesspits and the groundwater interact. There's also some separate research on how groundwater behaves under sea level rise. I can't say I've seen a study that looks at the whole thing holistically and looks at projecting what that water table might look like in, say, 20, 30, 50 years. But it's absolutely something we should be considering. How does the groundwater behave with the cesspit system and then also with sea level rise as well? Yes. Mhm. That, thank you. I'll repeat the question again. The a lot of the measures that I listed were that are being undertaken by the different sectors of society seem to be primarily focused on mitigation. Yes, I agree. I think that the adaptation measures is a conversation that is ongoing right now. In fact, one of the items I listed there was a study being done by the Department of Planning. And so there are conversations going on right now, not just in the private sector and in the nonprofit world, but also in government about adaptation measures that we should be taking. What are the impact of things like sea level rise to sort of sewage systems and things like that? So yes, there is, in fact, the body of research that's been done in the science world often lends itself more towards thinking about adaptation measures. So I think there's good groundwork laid to look more at adaptation measures here in Bermuda. But it's worth thinking that, small islands, it's not like we have lots of land to retreat into, but we have a good history of resilience against storms. So I think that we have the tools necessary to really overcome some of these challenges going forward, and the historical sort of wherewithal and resilience to leverage as well. Mhm. Yes, and it's so again, sorry, I'll repeat the question again for the people at home, but the question was, is there a projection of how much land will be lost under sea level rise projections? And there is. It's not a great deal, I think. There are some very low-lying areas that we need to look very critically at, but by and large, it's not like Bermuda is losing a great proportion of its landmass. It's more, in my opinion, it's more about the potential for extreme events flooding places that haven't flooded before, periodically, as opposed to all at once. When we start talking about, and I did show only the next 50 years because I wanted people to sort of get some sense of, this is in a person's lifetime. This is something that we will be seeing. Most of us will be seeing in our lifetime. But there are projections that go out to sort of 2200 as well, which show it being worse and then getting better again as we move away from fossil fuels as well, even under the worst case scenarios. There's a question at the back I saw. So so the question was, there's a group of people that deny that climate change has anything to do with human influence. Is that fair to say? And in my opinion, does that have any basis in science? The answer is no. There is irrefutable evidence that points to, that links our emissions of fossil fuels with, our emissions stemming from the combustion of fossil fuels to the gradual increase in temperature. And this is something that has been studied and understood for decades. I believe that those that would benefit from the ongoing emissions of combustion are those that have purported to try to debunk these claims, try to discredit them, and try to actively market against them. And there's no basis in science for it. I'm not sure if we had any questions from the people sitting at home with a glass of wine. Well, I'm not hearing any, so I think at this stage, I'll say thank you once again very much to the Department of Culture for hosting this event, and I look forward to the next one. Thank you.